Hello friends. So in today's video we are going to cover one more good question which has come in Iran Olympiad, as you can see, in 2011. And now this question looks a little bit scary. As you can see, I have drawn a diagram as well because it would be a little bit lengthy. And now let's read the question and let's understand how we can use this question and how we can solve this question. This question uses power of point concept, and which is very easy concept, but it is very hard to apply. So it's a good example of that. Now we are going to start reading the question. The question says, in an acute triangle ABC, angle B is greater than angle C. So as you can see in diagram, I had take care of that. Let M be the midpoint of BC. So let me mark for you. So this is the M as the midpoint. And now M is the midpoint of BC, and let E and F be the altitudes from B and C. So as you can see, point T and point F are marked in the diagram. Now it is also saying is that let K and L be the midpoints of ME and NMF respectively, and let T be on line KL such that TA is parallel to BC. So we have to prove that TA equals to be TM. So I'm not going to take time in the explaining the question because I have drawn a diagram for you. And yes, we have to also learn to how to make good diagrams, and this is the question. And now let's start using this question. Now before I solve this question, if you want to solve this question for yourself, here this is a hint for you. I have drawn a circle here. As I told you, it will use power of point concept, so it's a hint for you. Anyway, let's start solving this question. Basically here power of point is nothing. I'm going to tell you really quick that what is the power of a point definition. If there is a circle with center O, suppose, so we have center O, you can skip it if you know already by 2 minutes. And now I'm going to take a point B outside this circle, and suppose if it's a tangent to point T, that is PT is tangent to the circle like this, and so the power of point will be defined to be as PT square in this case. So if there is any random point P, if I draw tangent through point P on a circle O, in this circle suppose omega 1, then PT square will be the power of point. The second definition is PO square minus R square, that is PO square minus the radius of the circle R square. And the last definition of the power of point is that if there is a secant like this which is intersecting the circle at point A and B, so power of point would be PA into PB. So these are the three alternate definitions of power of point. We are going to use two of them, and the third one is just we are not going to use the third one. You can guess it right now. So in this case we are going to do a construction, and the construction, as you can see already in the screen, we are going to construct the circumcircle of the points A, F, H, E. If you remember that CF is perpendicular to AB and BE is perpendicular to AC. So as you can see, opposite angles sum up to 180 degrees. So AFHE is concyclic, H is the orthocenter, as you can see in the diagram. So I have drawn the circumcircle of the points AFHE, as you can see. And basically there is a property. If you don't know the property, let me just write the property for you. So the property we are going to use is that in this case, that if a line parallel to BC, that is in this case TA, so as T is parallel to BC, so the line TA and the segments MF and ME, ME and TA, that is the line parallel to BC, all three would be tangent to the circle AFHE, the circumcircle. Let me, I'm going to label to be as omega 1. So basically omega 1 is the name of the circle. So TA, that is any line parallel to this side BC. If I draw any line parallel to BC which intersects point A like this, so that line would be the tangent to this to this circle, first point. MF would also be a tangent to this circle, and ME will also be tangent to the circle AFHE, that is the omega 1. And this is the property. Basically why it is like this, you can prove it yourself, but it is the property. TA, MF and ME, all three are the tangents of this circle. And now here's the fun part, that as it is the tangents, and as we know that K and L are the midpoints, basically LF equals to be as LM and KE equals to be as KM. Well, basically all four will be equal, but we only require these two sets. But but basically as they are tangents, so this all 4 line segments would be equal. So now this is the construction which is very difficult to spot, but this is the construction. What we are going to do is, you have to pay attention here. I am going to draw one more circle. I have not mentioned this diagram for a reason. I am going to draw, so this is the construction. Let me write as a proof here. So this would be the answer. Wait a second. So this is the answer of this question. So this is a construction. The construction is, we are going to draw, please here you have to see carefully, draw a radius 0 circle, like this, with center M. So with center M. So let me just, I'm going to write it fast, with center M. So I'm going to draw radius 0 circle with center M. Now you must be asking that how we can draw circle with radius 0. It would be a point only, it is a point only, but we are going to consider that its circle has radius 0. But we are going to consider to be as a circle. Let's say this circle is omega naught, omega 0. Now basically, if I told you the definition of the power of point, I just told you just now. So basically, what's the definition? So suppose if I want to find the, this is the observation basically. So first observation I want to say is that power of a point of point k, of point k in omega 1. What is it? So I want to ask you that what is the power for point k at omega 1? So in this case, this is the point k, this is the point k, this is the circle omega 1, that is circle, and I told you there are 3 definitions of power of point. As you can see, ke is a tangent to this circle omega 1. So by the definition which I told you, ke square, that is ke square, must be the definition of power of a point. Ke square is the power of point k respect to omega 1. And what is the power of point of point k but respect to omega naught? That is this radius 0 circle. In this case, the power of a point would be km. The power of point would be km square. That is the m is the center, no? That's why I have told you po square minus r square is also a definition of power point. That's why. So km square minus r square. What is r square in this case? Radius is 0. So basically the power of point k respect to omega naught is km square minus r square, but here r square is 0 only because we have drawn a radius 0 circle, which is km square. And if you see, ke equals km. Why? Because they are the midpoints. Henceforth, what we can say is that power of point of omega 1 equal to the power of point omega naught. That is, the k has the power of point of omega 1 respect to of k, and the power of point of k respect to omega naught is equal. Similarly, I can say the same thing for the point L as well. So if I just rewrite this thing, I'm going to erase a little bit here. So if I say rewrite the same thing, that is, let me see here, same thing with point L this time. So power of point of L respect to omega 1 is LF square. Power of point of L respect to omega naught is LM square minus R square, which is 0 only, and LF equals LM cause they are midpoints. So they are midpoints. Basically what I'm trying to say is that power of point of K respective to omega 1 omega naught is equal, and power of point L respect to of omega 1 and omega naught is equal. And if you know carefully, I want to tell you, if you don't know, if there are 2 points, such that if there are 2 circles and there are 2 points, such that the power of point of one point equals power of point of other point respect to different circles, and the power of point of same point is equal to power point of different circle like this, that is the power of point of k and power of point of L is equal both in omega 1 and omega naught. So basically what we call is that line, that is in this case LK, this line is the radical axis of the omega 1 and omega naught. This is the radical axis. Radical axis, the definition is simple. A radical axis is a set of points such that any random point on a radical axis will have the same power of the point of the first circle, and it will have the same power of the point of the second circle basically. And as we know, that k will lie on that radical axis, L will also lie on the radical axis, it is enough for us to conclude that KL is itself as a radical axis. If we don't know, we can conclude like this. So basically T lies on the radical axis. So T also lies in the radical axis. And the radical axis definition I have told you, a set of points such that the power of the points of both circles is equal with respect to the same point. So I'm going to write right now. So we can say that note LK is the radical axis of omega 1 and omega naught. What it means, T also lies in the radical axis, if you know, as the question says. So as T also lies in the radical axis, so therefore I can also state that the power of point of omega 1 T equals to the power of point of omega naught T, like this. So what is the power of the point of T with respect to omega 1? The power of the point of point T with respect to omega 1 is T square. Why is that? Because I have told you in the starting, TA, MF and ME, all three lines are tangent to this circle omega 1. So power of point of omega 1 respect of T, power of point of T respect to omega 1 is TA squared. And the power of point of omega naught T is Tm square minus R square. But what is Tm square minus R square? R square is 0. So it equals to be Tm square. Like this. And this tells us that TA equals to be as Tm. And that's how we proved it. So hence and fourth we have proved it. This question is pretty good. This is not one of the best questions, of course, but this question has to do with that how we have to know that how we are going to conclude that when do we have to draw a radius 0 circle. If you want to ask that how we know that how we can draw radius 0 circle, it is simple. If first of all you have to locate a circle, as you can see I was able to locate a circle. Second of all, if you are using the radius 0 circle, most of the cases you're going to prove a line to be radical axis, like we have proven KL to be the radical axis. So in one circle it has to be a tangent, that is in this case KE is the tangent line, and in the second circle it has to pass through its center, like this. So KM is passing through the center of omega naught, but KE is the tangent to omega 1. So for like that. So the point, if I want to prove and I have to use this omega naught concept, that is radius 0 circle. So for that I should have a circle such that I know the length to the tangent of that. In this case I know that KE equals to be KM and K is tangent to it. And in the second case, here KM is the point where it is conquering. So by that logic, I can say that constructing a radius 0 circle with center M would be helpful for me. So like this we can see that when to construct radius 0 circles. Basically, you have to make sure that we have to first of all note which lengths are equal. Second of all, you have to note that they have to be concurrent. In this case, this all are concurrent to point M. That is MF and ME are concurrent to point M. And second of all, there should be a circle which I have drawn myself. And like this, I have got many hints to say that I have to use radius 0 concept. So that's all my friends. So this is the question of the radius 0 circle and the power of point. It is a little bit hard to see, but I have told you and it is pretty easy question. And again, by same thing, if I put any random point, suppose point U, and if I pass through point M, that is UM, and if I draw a tangent line like this, something like this, here as you can see, like UM and something tangent like this, suppose this point is V. So UV equals to be UM by the same logic. And thank you for watching this video. That's all in my side. Thank you for watching this video.